Hi, my name is Steve Bowler, and in this video we're going to go over the following. We're going to go over BGP communities, the BGP wait attribute, the BGP multi-exit discriminator or MED attribute, external BGP multi-hop, and BGP update source loopback, and how to implement those on our routers. So as you can see here in our diagram, we have Autonomous System 100, which is the customer, and Autonomous System 200, which is the ISP 1 router 1 and ISP 1 router 2. You have basically two connections from the customer to ISP 1. You have a T1 line and a T3 line, and we have the 4 loopbacks on the customer router that I created to simulate the customer networks. And over here on the ISP side, we have RIP version 2 running as our interior routing protocol, our IGP. So let's get started here and get these routers configured. Under customer router, what I'm going to do is I'm going to enable BGP 100. That's the local AS. And I'm going to go ahead and peer with ISP 1 router 1. Neighbor 130.0.1.2, that's the far side, and put in here remote AS200 to specify our neighbor autonomous system. And I'm going to go back and I'm going to configure the update source loopback 5. We're going to be using our loopback 5 interface for the BGP updates to come in on. Instead of the physical interface, we're using our loopback interface. And we do that with the update source loopback 5 command. And I'm also going to specify for my neighbor here the eBGP multi-hop command, and I'm going to set this to 2. Yeah, all this command is doing is basically saying in the normal BGP configuration, eBGP connection, you'd be peering directly to the interface IP address, the physical line. With the eBGP multi-hop 2 command, this is letting me change the time to live value of the packet to 2, which allows me, basically I'm changing the hop count. So instead of just being a single hop, single hop from one interface to another, I'm saying, hey, it's going to be eBGP multi-hop 2, and basically saying that the other hop is to my loopback interface. So we're just changing the time to live to 2, basically changing it from the default value from 1 to 2. Okay, and I'm going to go over here to my ISP 1 router, ISP 1 router 1, and I'm going to configure router BGP for local AS 200, and then here I'm going to peer with neighbor 130.0.1.1, which is the customer router, and here I'm going to specify the remote autonomous system here is 100. And I also have a loopback on my ISP 1 router 1. Loopback is 1.1.1.1. So I'm going to configure my neighbor. I'm going to receive the updates from this neighbor are going to be going to loopback 1. And the the only way this will be allowed to happen is if I set the following command, which is BGP multi-hop 2. Again, this is changing the time to live value from default to 1 to 2. Without this, the TCP connection will never come up. And external BGP multi-hop is usually implemented when you have two external neighbors which are connected, between multiple links, such as, multiple ATM or frame relay, virtual circuits. So if one of those circuits goes down and the connection can be alt routed, well, you have, your eBGP multi-hop set up to 2 or more, so that it won't be affected by, such a circuit to go down. Now, the last thing we're missing here is a static route on each side. For instance, on a customer router, we need to know how to get to the loopback interface of the other side, and vice versa. So here I'm going to create an IP route to 1.1.1.1. Specify the subnet, the mask. It's all what we call a host mask. All values 255s are set, and then we just specify the outgoing interface. Or the neighbor's interface would be, physical line on this would be 130.0.1.2, and go here on ISP1 and we'll do the same thing, just point it to, we need to create a static route pointing to the customer's loopback interface. IP route 5.5.5.5, again, that is customer's loopback interface. The host mask of all 255s, and we're just going to create the next hop would be 130.0.1.1, which is our connection to customer 1, and then hit enter.